Hello, AMC students. I'm just going to do a few problems from the review. I'm looking at the logs team assessment document. I'm not going to do all of them, but I'll just do a couple here and there throughout and explain my thinking. So question one, rewrite as a single logarithm. So I'm using those properties of log, so moving powers around, transforming multiplication and addition, and transforming subtraction and division. I'll do problem B. If I look at problem B, the first thing I notice is there are those coefficients in front of the logarithms. Those become the powers of the inside. And so I can rewrite the first part as log base 3 of 11 squared plus the second part, log base 3 of 81 to the 1/2 power. Now we can combine that all into one logarithm because when you have addition, you can switch that into multiplication. Log base 3 of 11 squared times 81 to the 1/2 power. We can go even better because we know what 11 squared is. We know what 81 to the 1/2 power is. So we have log base 3 of 121, because that's 11 squared, times 9, because that's 81 to the 1/2 power. And we can even do one more step here. 121 times 9. What would that be? 1089? Could be. Might have made a mistake. And so that's the idea, using the properties of logarithms. I'm going to scoot down a little bit and do some problem 3. Okay, there we go. When you look at problem 3, there's a kind of a variety of different problems. And remember that the ln here is really just log with a base of e. So these two problems, C and E, are kind of working together. I will do problems A and B. Okay. Oops. Wow, now there we go. My little screenwriter changed on me. So I'll do problems A and B here. When I see a logarithm with a base of 6, I'm going to use an exponent with a base of 6 to cancel those out. And so when I use base of 6, I get 5x plus 30 equals 6 to the 4th power. Let me pause here. Okay, sorry about that. I had to take a quick call. On the right side of the equation, I have 6 to the 4th power. If you do 6 to the 4th power, you get a big number. 6 times 6 times 6 times 6, 1296. So 5x plus 30 equals 1296. Then you can take away 30 from both sides. So you have 5x equals 1266. Divide by 5, and you get x equals 1266 divided by 5, 253.2. Now, I don't really need to worry about an extraneous solution because it's a positive number, and then the input is all positive right there. So there's nothing really to worry about. When I look at question B, it's sort of the inverse. I'm solving an exponential equation, so I do things backwards. I divide by 725, divide by 725. So I have 3 to the negative 4x, 1500 divided by 725, 2.069. Next up, I have a base of 3, so I'll use a log with a base of 3. Log with a base of 3. And so you have negative 4x equals log base 3 of 2.069. Now, at this point, you're going to use the change of base formula. The change of base formula allows you to evaluate a log when a base is not 10. And the way you do it is you just keep the base on the bottom. You rewrite it as log of the input divided by log of the base. Okay. You can also type it into a calculator. There are some calculators online that have a log base function, or you can use the change of base formula. And so I'm using my calculator on my phone. And excuse me, let's make that work. So if I want to take the number that I just had and take the log of that, and then I want to divide that number by the log of 3. So my top number was 0.3158. If I do the log of 3, I get 0.4771. And I'll just do the top number divided by the bottom number. 0.3158 divided by 0.4771. And I get so negative 4x equals 0.6619. Divide both sides by negative 4. You're good. Again, here you actually won't have anything to worry about with an extraneous solution because it is, and it says round to the nearest hundred, so I'll bring that right to, instead of 0.16, 0.17. You don't have anything to worry about with extraneous solutions because our equation's exponential, it's not logarithmic. Okay, we'll just do a couple more problems with this video here. So when I look at these ones, they're a little bit more challenging. You're going to have to use one of the log properties to solve them. So like equation G. I see subtraction on the left side, and subtraction can be transformed into division. So you have log base 6 of x divided by 5 equals log base 6 negative 2x plus 14. Because they're both log base 6s, you use an exponent with a base of 6 to invert and cancel it out. And then you have just a regular linear equation, x divided by 5 equals negative 2x plus 14. Get your x's on the same side, add 2x to both sides. If you have x divided by 5, that's the same as 0.2 divided by 5 is the same as 0.2. And so you have 2.2x is equal to 14, and then divide by 2.2. Okay, so let's do 14 divided by 2.2. And that gives me x equals 6.36. So I should be careful here about extraneous solutions because we have this negative 2x inside the logarithm, but we're okay because if I plug in 6.36 for x, that still is positive. Negative 2 times that plus 14 still ends up positive, so we're okay with this. So in this video, I'm just going to do one more problem. Don't want to make it quite too long. I'll just do problem 4 here. How long will it take to double 1,000 at an interest rate of 6.35%? We've got our formula right there. You remember that from our exponential unit. So if I double $2,000, or if I double $1,000, I have $2,000. So that's my A. 1,000 is my P. 6.35% becomes 0.0635. Monthly, 12, raised to the 12t. Now we're just solving this like we've solved some of the other equations. Divide both sides by 1,000. So we have 2 equals 1 plus 0.0635 over 12 raised to 12t. Next, I'm going to make that base into one number. So if I go 0.0635 divided by 12, add that to 1, I can see that my base is 1.0053. So that's the logarithm I'm going to use. I'm going to use a log with a base of 1.0053. Because that will cancel out the exponent. So log base 1.0053. Use the change of base formula so that the 1.0053 stays on the bottom. This is going to equal 12t. So just bear with me for a second. I'm going to get a couple calculations in here. We'll do the log of 2 first. Log of 2 is 0.301. Then log of 1.0053 is 0.0023. So I do the top divided by the bottom. 0.301 divided by 0.0023 is 130.87 equals 12t. Divide that by 12. We have our answer. It will take 10.91 years. That's my value right there. And so that concludes this video. I really encourage you to spend the rest of your 20 minutes studying on some other problems like these. Thank you.